Hello students, welcome back. In this part, we'll discuss some previous year's JEE questions. So let's start. Now it is the time to solve some JEE problems, some previous year JEE problems, to learn about how to solve the questions from this chapter. Okay, so there will be some numericals as well as there will be some conceptual questions that are also in the exam. So you should be good at both the things in order to tackle any problem given in the exam. So first is, let's discuss the first problem. A compound is made up of A and B atoms. Have a crystalline structure in which A forms hexagonal close packed structure and B occupies 2/3 of the octahedral holes. So what will be the simplest molecular formula of the compound which is made up of A and B? Okay, so options are A3B2, A2B3, A4B3 and A2B5. So how to solve this question? So let's write down A is HCP and B is occupying 2/3 of octahedral holes. So if A is occupying HCP, that means HCP unit cell, it has how many? This structure has 6 atoms of A, so there will be 6 atoms of A present, and so if the number of close packed atoms is equals to 6, then the number of octahedral voids or octahedral holes is also equals to 6. So out of the 6 octahedral holes, only 2/3 is occupied. So 2/3 of 6 is how much? It is 4. Okay. So there will be 6 atoms of A and there will be 4 atoms of B. So which comes out to be A3B2. A3B2 will be the simplest molecular formula, that is option A is the correct option. Okay. So let's move to second question. Problem 2. In which of the following crystals alternate tetrahedral voids are occupied? Options are NaCl, ZnS, calcium fluoride, sodium oxide, trisodium oxide. So if you see in NaCl, the chloride ions they'll occupy the CCP and the sodium ions they'll occupy the all octahedral voids. So this is not the correct one. Alternate tetrahedral voids are occupied in zinc sulfide, where the zinc ions they occupy alternate tetrahedral voids, whereas in calcium fluoride, like the fluoride ions they occupy all the tetrahedral voids, and this is fluoride structure and this is anti-fluoride structure. So in both of them alternate tetrahedral voids are not occupied. So only in zinc sulfide alternate tetrahedral voids are occupied. Okay. So option B is the correct option. Let's move to the question number 3, the problem number 3. So a compound is formed by elements A and B. So this crystallizes in the cubic structure where A atoms are at the corners of the cube and B atoms are at the body centers. The simplest formula of the compound is. So most of the questions they'll ask you on the basis of writing the formula of the compound. They'll say that A occupies this thing and B occupies some other thing. They occupy in some other way. So you have to determine the simplest formula. So the more questions that you solve on this model, so the more easily you can solve any question asked in the exam. Okay, they may twist you in different ways, but if you have a good enough practice in solving these type of questions, then it is really easy for you to tackle any question given this kind. Okay, so the simplest formula of the compound is, these are the options. So let's find out the answer. Elements A and B. So first always write A and B. So A atoms are at the corners of the cube. So corners of the cube. So it will be 1/8 into 8 is equals to 1, and B atoms are at the body center. So, B which is present at the body center will completely belong to the unit cell. So, the number of atoms of B will be 1. So, it will be A1 B1, that is AB, right. So, it is very simple. The simplest formula of the compound is AB. So, option A is the correct option. Okay. So, this is problem 3, which is also very simple thing, and let us move to the next question, problem number 4. Yeah, this seems to be a difficult question. Okay, so don't worry, we'll tackle the question and I'll tell you how to solve this question. So, in a crystalline solid having formula AB2O4, oxide ions are arranged in cubical close packed lattice, while cations A are present in tetrahedral voids and cations B are present in octahedral voids. So, what percentage of tetrahedral voids is occupied by A? Okay. So, let us write A and B and O. Oxide ions are present in CCP or FCC structure arrangement, but atoms A are present in tetrahedral voids and atoms B are present in octahedral voids. Sorry, cations B. A and B both are cations and they present, A is present in tetrahedral and B is present in octahedral voids. So, the question is, what percentage of the tetrahedral voids is occupied by A, cations A? What percentage of tetrahedral voids is occupied by A? Okay, let us find out. Here, start the question from oxygen. So, oxide ion CCP arrangement. So, in CCP you have at all the corners and all the face centers are occupied. So, corners 1 by 8 into 1 by 8 into 8 plus 1 by 2 into 6, so it will be 4. So, there are 4 oxide ions, right. So, if you know that if a number of the close packed atoms is equals to 4, then there will be double the number of tetrahedral voids. So, there will be 8 tetrahedral voids and there will be 4 octahedral voids, right. So, it is O4 because 4 oxide atoms are there, 4 oxide ions are there and we have A and we have B. Okay. So, to have 2 at B, out of 4 cations, only half should be occupied, that is 1 by 2 into 4 will come 2, right. That means 50% of the octahedral voids should be occupied. So, then only you will get B2, okay. And let us come to A. A, there is only one cation A present per unit cell, right. So, that is possible only if out of 8 only 1 is occupied, right. 8 into 1 by 8, that will become 1. So, out of 8 tetrahedral voids available, only 1 will be filled up, right. So, yeah, only 1 will be filled up, that is 1/8 of the tetrahedral voids are filled. So, 1/8 into 100, that will give the percentage of tetrahedral voids filled. So, 50 by 4 will become 12.5%. 12.5%. That means only 1/8 of the tetrahedral voids are filled. So, 12.5% of the tetrahedral voids are filled and 50% of the octahedral voids are filled, right. Out of 4 octahedral voids, only 2 will be filled up. So, 50% of octahedral voids are filled. So, this is the question. So, basically this is about the spinal structure. So, if you understand the spinal structure, then you can easily solve this question without doing all this. So, let us move to the next problem. Problem 5. In closest packing of atoms, the size of the tetrahedral void is greater than that of octahedral void. So, option A. The size of the tetrahedral void is smaller than that of octahedral void. The size of the tetrahedral void is equal to that of octahedral void. The size of the tetrahedral void may be larger or smaller or equal to that of octahedral void depending upon the size of the atoms. Okay, this question seems to be a bit difficult, but no problem. we can do it in closest packing of atoms. So it is about the size of the tetrahedral void and octahedral void. Which is bigger or which is smaller? Which is bigger, which is smaller? That we need to find out. So if you recall that the radius of cation by the radius of anion, this will be 0.225 for tetrahedral void, and for octahedral void this will be what? This will be 0.414. Okay. So radius of cation should be 0.225 times radius of anion, and here the radius of cation should be 0.414 times radius of anion. So from this you can see this value is higher, right? So this is octahedral void. So since this value is higher, the size of the octahedral void will be always higher than the size of tetrahedral void. So tetrahedral void is smaller in size. So size of the tetrahedral void is greater. So A is wrong. Size of the tetrahedral void is smaller than that of octahedral void. So option B is the correct option, right? So this is the problem number 5. The tetrahedral void and octahedral void sizes are not equal. So even the D is also false. Okay. So these are five questions. 5 questions on the chapter, based on the chapter solid state. Some of them are theory questions and some of them are numerical type question. Like, you don't expect numerical type questions, many numerical type questions in this chapter, but most of the questions are on packing fraction, and also about the closed packing structure, coordination number, right? And there is a scope that they'll ask questions mainly on the based on the structure of some ionic compounds, right? So it is really important to understand as well as to remember the 6 different types of ionic compound structures I discussed: AB type, AB2 type, A2B type, etc. Okay. So if you're good at this structure of some ionic compounds, as well as the way to how to find the simplest formula of the compound. Okay. So if you're good at these particular things, then it will be very easy for you to score, though they ask you tough question, even the tough question in the solid state chapter. Okay. While studying this chapter, if you get any doubts, you can post it for free on askIITians.com. How? First, open the website, and if you see at the top right, you will see a discussion board. So simply click on that. It will take you to the next screen. Yeah, in the next screen you will see the Ask Experts, a separate section on the right hand side. So select a relevant category for your question and simply post your question here. We experts at askIITians will provide answers to your questions within 24 to 48 hours. So students, this is all about the chapter solid state. I covered all the concepts which are important for JEE purpose. So before ending this, let's quickly summarize what we all learned in this particular chapter. We first discussed about the definition of a solid, and we discussed about the types of solids: crystalline solids and amorphous solids, and we focused entirely on the crystalline solids. We have seen the classification of crystalline solids and their properties, and then we moved to the concept of crystal lattices and unit cells, and we discussed about the various types of unit cells and various types of crystal systems we have, and we also discussed about the simple cubic, the face centered cubic, and body centered cubic and end centered cubic unit cells. And then we moved to the concept of closed packs structures. We have seen that how we can arrange the spheres in 1 dimensions, in 2 dimensions, and finally in 3 dimensions. So in 3 dimensions we have 2 types of structures mainly, that is, one is hexagonal closed packed structures and cubical closed packed structures. And then we also learned about the coordination number of these structures, and then we discussed about the concept of voids, tetrahedral voids, octahedral voids. We have located these voids by taking CCP unit cell as example, We also calculated the sizes of tetrahedral and octahedral voids, and then we discussed about the concept of the structure of some more common ionic compounds. In that we discussed about AB type, AB2 type and A2B type structures, and we also discussed about perovskites and spinel structures. And finally we discussed about the imperfections or defects in crystals, Schottky defect, Frankel defect, vacancy defect, and finally interstitials defect. We also seen how these defects affects the properties of the crystals. So stay tuned on askIITians.com for my more upcoming videos and videos of other subjects like maths, physics, chemistry and biology. Thanks for watching. I hope you enjoyed with this presentation.